Welcome back to The Explainer. So, today we're unpacking this absolutely fascinating logistical nightmare that actually dictates the livelihoods of millions of people. Think about it. How exactly does a country get water from these colossal, monumental mega dams all the way down directly to tiny individual crops? We're going to trace a journey that spans over 50 years. We're looking at how India went from literally moving massive mountains of earth to deploying smart, internet-connected sensors right into the soil. It is this wild story of engineering, human behavior, and cutting-edge tech. So let's just dive right into it.
Okay, so first we have to understand this massive post-independence paradox. After independence, India went all in and built this gigantic network of dams, canals, reservoirs. The investment was just monumental. But by the time the early 1970s rolled around, a pretty glaring problem popped up. There was this huge, massive gap between the irrigation potential they created with these mega projects and what was actually being used by the farms. Millions of hectares of land just weren't getting the water they were supposed to. You had the water, right? And you had the farms, but that connection between the two was completely broken.
To understand how they set out to fix this, we really have to talk about what's called the command area. Best way to think about this, think of the mega dams and the main canals as your interstate highways for water. But, you can't just drop an interstate highway in the middle of a neighborhood and expect everyone to instantly get to their driveways. You need local streets, you need avenues, you need the actual driveways. The command area is basically that local region. And command area development is the systematic planning to make sure that water actually navigates those local streets and reaches every single farm efficiently. It is the literal last-mile delivery of agricultural water.
Recognizing this missing last mile, the government officially launched the Command Area Development Program, or CADP, back in 1974. And man, over the decades, this thing has evolved drastically. It was renamed CADWM in 2004 just to put a heavier emphasis on the water management side of things. Then in 2015, they folded it into the much larger PMKSY initiative. And now, well, it's culminating in this crazy high-tech modernization rollout set for 2025. So it went from a 1970s initiative where guys were just digging basic canals to a highly sophisticated data-driven mission.
Now, in those early days, the focus was entirely on what we'd call the hardware. We're talking heavy, physical earth moving. They literally had to construct on-farm development works and all these critical link drains. A lot of the older projects were running way below capacity, so they had to go in and fix system deficiencies, desilting the channels, patching up weakened canal banks, and even reclaiming land that had ironically become completely waterlogged because of terrible drainage. You essentially had to build and pave those local streets before you could even think about directing the traffic.
But once those channels were finally dug, how do you actually make sure everyone gets their fair share? That brings us to this absolutely crucial regulatory concept known as Warabandi. This is a rotational water distribution system. The program installed measuring devices and adjustable modules right at the outlet heads to strictly enforce a schedule. The whole point was to guarantee that getting water wasn't just some chaotic free-for-all, but an equitable, perfectly timed supply that farmers could actually rely on when they were planning out their crop seasons.
Because, think about it, without a strict system like Warabandi, you run into this massive geographical conflict. It's the classic battle of the head enders versus the tail enders. If things aren't strictly managed, farmers whose lands are right at the start of the canal, the head enders, they're obviously going to tend to take more water than they really need, which naturally leaves the tail enders, the guys way at the very end of the line, with completely dry fields and super erratic supplies. And of course, the head enders had a huge vested interest in keeping things totally unregulated, which just created massive tension.
So the real crucial takeaway here is that physical infrastructure, the hardware, is absolutely not enough. You desperately need the software. And in this specific context, the software is human cooperation. The program leaders realized that without the active participation of the actual people using the water, these systems were never going to run efficiently. This realization led to a massive push for what they called Participatory Irrigation Management, or PIM. The core idea was actually pretty radical for the time. Take the power and the responsibility of managing water distribution away from the government engineers and transfer it directly to the farmers themselves.
But to make a massive transfer of power like that actually work, you need structure, right? So the government provided a model act to the states to create a very clear legal hierarchy. At the local hyper-specific outlet level, you get a Water Users Association, or a WUA. If you combine 5 or more of those WUAs together, you form a distributory committee. And then, at the very top of the entire irrigation project, you have the project committee. This setup gave real, tangible responsibility to the farmers, not just to divvy up the water, but to handle the maintenance and even help collect the water charges.
Just to put this into perspective, I want you to hear this number, 17.84 million. That is the staggering number of hectares of agricultural land in India currently covered by these water users associations. Tens of thousands of these farmer groups have been spun up across various states. It's an absolutely monumental administrative shift. We're talking about turning millions of individual, everyday farmers into active, organized managers of their own local infrastructure.
But okay, let's be real here for a second and acknowledge the reality on the ground. Handing over massive, highly technical infrastructure to completely untrained farmers was definitely not some overnight success story. There were massive constraints. In a lot of states, there was basically zero legal backing for these groups. The physical systems they were inheriting were often already broken or completely silted up. The farmers were terrified they wouldn't have the money to maintain them, and those old conflicts between the head enders and tail enders, yeah, those didn't just disappear. Plus, just asking a regular farmer to suddenly do the job of a seasoned civil engineer was an incredibly steep hill to climb.
The government, to their credit, totally recognized these immense hurdles. So, as you can see reflected in the National Water Policy, they made it a formal directive to progressively involve farmers. And they didn't just pass laws and say good luck. They tied central financial assistance directly to the formation of these water users associations. They rolled out one-time functional grants to give these groups the literal seed money they needed for operations. It was a complete shift in strategy, from just paying to build canals to actively funding the community management of those exact same canals.
And alongside that financial backing, there was this other really crucial demographic push, actively empowering women in water management. Women make up a massive, absolutely vital portion of the agricultural labor force in India. So the guidelines explicitly emphasized that states needed to ensure women were actually represented on the managing committees of these water users associations. It was a really smart way of utilizing regulatory means to drive gender empowerment in the very decisions that directly affected their daily livelihoods.
Okay, let's fast forward to right now. Despite all this incredible progress, the reality is that traditional flood irrigation has its limits. So the Union Cabinet recently approved this revolutionary sub-scheme for 2025 to 2026 called the Modernization of Command Area Development and Water Management, or MCADW. And this right here is where our story completely pivots from 20th century canal digging straight into 21st century precision agriculture. To kickstart this revolution, the government gave the green light for a substantial initial outlay of 1,600 crore rupees. That funding is specifically targeted for pilot projects that are going to be rolled out across various agroclimatic zones all over the country. And they're actually using a challenge funding model for the states, which is totally designed to spur competition and innovation. I mean, this isn't just a minor upgrade, it's a massive financial commitment to completely reimagine how water physically reaches a crop.
Because what we are really talking about here is finally moving away from that old system of open dirt canal networks. Those old canals just constantly lose water to evaporation and seepage, and they're always getting clogged up with silt. The new vision? Robust, underground, pressurized piped irrigation networks that deliver water directly from the source all the way to the 1-hectare farm gate. It is quite literally like swapping out a leaky wooden bucket for a high-pressure industrial hose.
And they are attaching a serious tech upgrade to those pressurized pipes. The MCAD-WM program integrates SCADA systems, which, if you don't know, is the exact same complex control tech used in major industrial plants. And they're pairing that with Internet of Things sensors. So we're talking real-time water counting and monitoring. It completely eliminates the old manual guesswork. By combining those pressurized pipes with smart sensors, the ultimate goal is a massive, game-changing increase in water use efficiency right at the farm level. The goal is maximum crop productivity out of every single solitary drop of water.
But you know what's brilliant? The modernization doesn't stop at just the water itself. It actually extends right into the local economy. The modernized scheme includes 5 straight years of dedicated hand-holding to link these water user societies with much larger economic entities, specifically farmer-producer organizations and primary agricultural credit societies. The strategy is to make irrigated farming highly modern, heavily tech-driven, and economically integrated. And by doing that, the government is hoping they can actively attract the younger generation back into farming.
So, based on what they learned from these pilot projects, a massive national plan is officially slated to launch in April 2026. From literally digging basic dirt channels with shovels in 1974 to deploying underground IoT-enabled micro-irrigation networks today, it really begs the question, can smart tech and empowered farmer groups finally close that last-mile gap once and for all? It is a monumental shift in agricultural technology, and it's definitely something we absolutely need to be keeping a close eye on. Thank you so much for joining me today on this explainer. I hope you found this whole evolution as fascinating as I did.